Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the starting material. The starting material is the carboxylate anion of 2,3-dichlorobutanoic acid. Wait, let me reread the structure. The structure shows a carboxylate, CH, with a CHCl group alpha to it and a CHCl-CH3 arrangement. So the starting material is the anion of 2,3-dichlorobutanoic acid, CH3CHCl-CHCl-CH. Moving on to the next step. Decarboxylation, CH2. Loss of CH2 from the carboxylate anion gives a carbanion or alkene via elimination. In decarboxylation of a beta-halo acid salt, loss of CH2 gives an alkene. With 2,3-dichlorobutanoate losing CH2, the alpha carbon, C2-bearing Cl, loses CH2 to give CH3CHCl-CH2 carbanion, but more likely it proceeds via an E2-type decarboxylation. Actually, for alpha-beta-dihalo carboxylates, decarboxylation gives the vinyl chloride or alkene. Let me reconsider. Starting material is CH3CHCl-CHCl-CH. Decarboxylation, loss of CH to the carboxylate loses CH2, and since there is a beta-chloro group, this is a beta-elimination type decarboxylation giving CH3CHCl-CH is equal to CH2. No. Actually, for alpha-halo carboxylate anions, decarboxylation gives alpha-halo carbanion which loses Cl to give alkene. So CH3CHCl-CHCl loses CH2 to give CH3CHCl-CHCl carbanion, which then loses Cl to give CH3CHCl-CH is equal to CH2. Wait, let me reconsider the structure. Looking again, the structure shows CH attached to CH, Cl attached to CH, Cl attached to CH3. So it is CH3CHCl-CHCl. Decarboxylation of alpha-chlorocarboxylate, loss of CH2 from CHCl gives CHCl carbanion, loss of Cl gives alkene. So A is equal to CH3, CHCl, CH is equal to CH2, but 1 Na, 2 vinyl chloride? No, 1 chloro, 1 propene from elimination of adjacent Cl. Actually, CH3, CHCl, CHCl, loses CH2 to give CH3, CHCl, CHCl, which eliminates Cl to give CH3, CHCl, CH is equal to CH2 or CH3, CH is equal to CH, CH3, but 2 Na. Simpler interpretation, the carboxylate is from 2,3-dichloro acid. Loss of CH2 from the carboxylate, beta-keto acid analogy, here with alpha-beta-dichloro, A is equal to CH3, CHCl, CH to Cl, 1,2-dichloropropane, by protonation, or an alkene. Moving on to the next step. A plus HCl, B. If A is an alkene, propene or similar, adding HCl gives an alkyl chloride. And for the final step, B plus a KOH, C aqueous KOH hydrolyzes alkyl halide to alcohol or causes elimination. Given the answer is A, propanol, CH3CH to CHO working backwards, C is equal to propanol. KOH, AK on B gives propanol, this suggests B is 1,1-dichloropropane, gemdichloride, since gemdihalides with a KOH give aldehydes. So B is equal to CH3CH to CHCl2 B comes from A plus HCl. A is equal to CH3CH is equal to CHCl, 1-chloropropene plus HCl CH3CH to CHCl2 Markovnikov addition. A is equal to CH3CH is equal to CHCl, 1-chloro-1-propene or allyl chloride variant. A comes from decarboxyl or CH3CHCl, CHCl, Co, loss of CO2 and Cl gives CH3CH is equal to CHCl, 1-chloroprop, 1-Na. This is consistent. The decarboxyl of the alpha, beta-dichlorocarboxylate gives alpha, beta elimination producing CH3, CH is equal to CHCl, A. Then A plus HCl, CH3CH to CHCl2, B, by addition of HCl with Cl going to C1. Then B plus a KOH, gem dichloride hydrolysis, CH3CH to CHCl2 plus to KOH, CH3CH to CHO plus to K close plus H2O. This gives propanol is equal to product C is equal to option A. Therefore, the correct answer is A. Therefore, the correct answer is option A.